Okay, well, let's move on to our second example. Okay, if let's say for the first example you watch already and you're still not very clear, please don't worry. Okay, you can always stop the video, rewind it, and watch it again. All right. Even if after watching it again you realize I'm still not very clear, Mr. Ng, what do I do? Don't worry. Here's a second example to help you. Okay, let's try it again. Okay, do not give up. We just keep trying. All right. Okay, second example, solve the equation 5 to the power x plus 5 equals to 30 bracket x to the power of, 30 bracket 5 to the power of x minus 1. So let's take a look at this exponential equation. This exponential equation, take a look, because your algebra is in a power, right? So there's one term here, two terms, and three terms. So for three terms exponential equation, what can we do? So like I suggested, most of the time we use the substitution strategy, alright? So for the start, so over here, let me try. So I will write everything out again. 5 to the power x plus 5 equals to 30 bracket 5 to the power x. Instead of power of minus 1, Mr. Ng can write it this way, right? This is the same as 5 to the power of x over 5. Right? It's the same, right? If you're not very sure, let's recall our laws of indices again. This is the same as 5 to the power of 1, right? When you divide two expressions with the same base, what do you do with the power? Divide two expressions with the same base, you subtract the power, right? So it's 5 to the power of x minus 1. See, 5 to the power of x minus 1. So we know they are the same. Okay, so from here, what you can do is you can start doing your substitution. Can let u, example, let u be equals to 5 to the power x. Okay, you can let any variable here, let u, let y, but don't let x be 5 to the power x. Otherwise, in your equation, you have two x's. We don't want that to happen. Okay, so over here, so I'll just replace my 5 to the power of x with u. Okay, so this is u. Okay, this is u. Sorry, this is u plus 5 equals to 30 bracket, and then I replace my 5 to the power x again with u. Okay, with u. Right? So far so good. So over here, isn't this a very normal equation that we normally solve? The 30 and the 5, I can even cancel it, right? Cancel it, so I have 6. Right? Because 30 divided by 5 is 6. So if I rewrite this equation, I will have u. Then I bring this, if I can bring the u to the other side, right? Subtract u from both sides of the equation. I have 6u minus 1u equals to 5. Correct? I just bring this u to the other side. So subtracting u from both sides of the equation. So 6u minus u equals to 5. So from here I have 5u is equals to 5. So therefore u is equals to 1. That's it. So yay! Can I pop the champagne and celebrate? Not yet, right? Why? But Mr. I solved for you already, what? Yes, very good. You solved for you already. But we must continue. Remember what are we doing? We're trying to solve the equation. We're trying to solve for x. We're not trying to solve for u, no. We're trying to solve for x. So let's continue, okay? Don't stop until you have found the value of x, okay? Don't stop at u, stop only when you have finished finding x, okay? Which is what the equation wants. So u is equals to 5 to the power 1. What is u again? U is actually 5 to the power of x, right? So 5 to the power x is equals to 1. So remember what do we do? For two terms exponential equation, make the base the same and you equate the power. The number 1 is the same as 5 to the power of 0, right? 5 to the power of 0. So now you make the base the same, you equate the power. So x is equals to 0. That's it. Okay? Then you may ask, Mr. But in an exam, how do I double check the answer? How do I know if it's correct? Very simple. Simply take x equals to 0, substitute into the equation. Make sure your 5 to the power of 0 plus 5, the value, punch your calculator, must be the same as 30 times 5 to the power of 0 minus 1. You punch the right hand side. Both the left and the right must produce the same value. Is that okay?